that look better?
Yeah, so we're live now.
You got to be okay. All right. Hello, everyone, and welcome to our presentation today on jMessenger. My name is Mark, and here on my team we have Tyler, Connor, and Deanna. And today we'll be presenting to you the jMessenger project management plan. First thing comes first, we have a problem in the company recently where we were developing a high-stakes critical project to generate company revenue with our clients. And due to our lack of secure infrastructure, one of our developers was able to copy the entire repository in the final stages of development, take it to one of our competitors, and they were able to release it before us, thus taking away a good number of our clients and really hurting our revenue stream from this high stakes project. This resulted in a huge loss of profits from our company, and so it became imperative that we developed a solution for this to avoid this happening in the future. Also, recently there have become some legal precedents as well. The Sarbanes-Oxley Act of 2002 also has made this apparent that we need programs like this. And then also a couple of side benefits is this as well. We've had problems dealing with our large teams. The more developers we get on a project, actually, the productivity seems to get less and less efficient. So we're hoping that jMessenger can approach this problem with a solution.
So the proposed project is to produce a prototype communication portal application to let our developers share their code more easily and also without exposing it on public servers so that it can't be stolen. The scope of the project is essentially that it has to be written in Java because that's what our development team is most familiar with. It has to store all of the communications in a remote database, something secure and owned by our corporation. It has to log all the code exchanged with those communications, and it has to use a secure communication protocol like Secure Shell or Hypertext Transfer Protocol, the secure version of that. So our chosen software development lifecycle, we went with a prototyping-based methodology. The code provided by management was already a prototype, so it makes sense to work on additional prototypes built off of that and just iterate through analysis design cycles to implement the features we need one by one until we've got a working product. The prototyping-based methodology was chosen so we could speed up the development, provide our development team with rapid feedback from the project sponsor and other users, and to produce these multiple solutions to go through all of our requirements. And pardon me. Sorry, I'm sick. I don't know if you guys know that. Can we cut this out of the video by any chance?
Totally. I can totally do it. No worries. Awesome. Just go ahead and start over on this slide.
Right. And so to iterate over, to produce, you know what, forget it. Just go to the next slide. I got nothing.
Okay, we'll come back to it later. Okay, and of course, with a team, you need team members. So our team will be composed of at least 4 different groups, namely analysts, designers, developers, and program testers. These groups, we want to keep them small, like we said before. We've had trouble in the past with larger groups, so keeping them 2 to 5 members each would be really helpful. It's recommended that there's no overlapping of individuals from one group into another, but in this case, it's allowable on an as-needed basis. We do encourage open and honest communication between teams to help facilitate the productivity on the project. To further increase productivity, we've displayed a list of what the qualifications will be for each of these teams. For the analysts, they'll need to be able to, of course, analyze and gather the information needed to create the program. That is their purpose. Development designers will be designing diagrams to help our developers. The testers, of course, will test the code, make sure there are no bugs, no problems with it. And their qualifications will vary, but overall, we're hoping to make sure each of these are fluent in Java. That way we can keep the project flowing. On the next slide, we have chosen the Lean software development methodology to kind of be our standard to measure against as we go through this project. The This methodology has been condensed into these 7 points to give you a quick glimpse at what this methodology will help us achieve. We will be eliminating waste or unnecessary and redundant code, amplify learning, making final decisions as late as possible to allow for more accurate programming, empowering the team to be their best, building integrity and responsibility, something that will help eliminate the possibility of the code being misused or hacked again or sold to other companies. And overall, we want to look at the big picture. We want to see what we can do to help our developers in the long run.
Who's got risk analysis?
I have no clue.
I didn't write it. I don't know it.
Okay, then
Let's see.
I guess skip
I
the
might-
slide.
I might be able to wing it.
Okay.
So if I understand this correctly, the risk description, that's just an example, correct? And then the consequence comes from that probability score. Okay. Impact. All right. So with the risk analysis, we've come up with 3 different risk factors, including corruption of shared repositories, hosting service for repository, GitHub, for example, becomes unavailable, and developer accidentally pushing data before pulling the actual version. So with each of these, we've kind of come up with an analysis of each. For corruption of shared repository, we have a consequence that could happen, that is parts of the shared repository may be rendered useless. This could delay an application's progress significantly. So we could lose code that is hosted on our servers. The probability is low, but the impact will be high. If this does happen, which on the rare chance it does, it could be devastating to our company. And so in order to combat that risk, we will have a local backup that is updated regularly, off-site, miles away, that will be protected. And once that shared repository is restored, the backup will be able to update the repository to its previous state, and all code will be recovered. Now, a hosting service for the repository becoming unavailable. The consequence could be that our developers are not able to push their latest updates to the repository, thus potentially delaying progress. So we could have all of our developers writing our code, but if we're not in communication with each other, then we really can't be making any progress. The probability is low that a repository like GitHub will go down, but it will impact us a little bit. Our progress will be delayed. So what we would have to do is our developers would wait to push their updates to the repository. If the problem were to persist for more than 24 hours, we can pushing to a backup or local repository that we have on site. That way we can reduce that delay in our progress. Now, what happens if a developer accidentally pushes data before pulling the actual version? This can create merge problems inside the repository that will need to be manually fixed. This could potentially delay progress depending on the last time the developer pushed the repository to his or her local machine. So, for example, we have somebody that has gone away on vacation and isn't caught up. When they get back, they haven't pulled what their developers on their team have already written, and they push something on, then we could lose stuff. And the probability of that is a medium. We give it a medium score because human error risk. The impact would be low because we have trust in our developers. They attend a best practice seminar in which they will be instructed, reminded of working in a shared environment. We will remind them of these risks and help them set up routines. Next slide. That's the wrong, oh yeah, there we go. So, can we build this? We believe so. We have quite a few small skilled teams, and we have faith in them that they will be able to do this and have it fully functional in as little as 3 months. Should we build it? Of course. This will help us protect investments in future projects. We will be safer, more secure. Our developers will be trained, and they will have a love for this because they have built it. We will also comply with Sarbanes-Oxley Act of 2002, making us fully complicit with the legal aspect of our company. And if we invest a little, we can progress a lot. So in conclusion, jMessenger will follow the prototyping-based methodology. We will build on what we've already started, and we will use Java with Java database language because it is our developers' strongest language, and they love it. Our small teams will be an efficient tool because they will have communication, and that communication being efficient will lead to success. And our lean software development methodology will bring us quality products in the fastest way possible. We have a need, and jMessenger is our solution. We hope that you will be on board with us and that we can get this rolling out as soon as possible. Cool beans.
Awesome.
Sorry for that risk assessment.
Oh no, you're fine. I
stumbling a
have
little
no clue whose slide it was.
It's all right. Don't worry about it. We're good.
It's great though. That was awesome. Yeah, we can hear you.
All right, so I don't know what happened, but sometime during the presentation, my mic completely fizzed out. The risk slide was mine.
Oh, that's fine.
Okay.
But I couldn't talk or anything, and then
Yes.
I couldn't hear you guys for a second, so I didn't know which